Hey guys, guess what? We're starting a new chapter today. We're on lesson 6.1 and we're going to talk about powers and exponents. So basically this chapter is going to be kind of a long one because it's really foundational with a lot of algebra basics in it. Things that you'll continue to go over. In fact, we're doing a similar lesson with the algebra kids. When is it happening? In a couple weeks. Okay, and they also did it in 7th grade. So this is super, super, super important information. Okay, so I'm going to write down a number, and I'm going to highlight it with its different colors. Okay, so this together is called a power. Okay, so let's define what power means. So power is a way to write a multiplication problem, where the factors, the numbers being multiplied, are the same. Okay. Now, the two components that make up the power is the big number, and he's called a base. And a base is the number that is multiplied by itself repeatedly. Okay. Well, how many times is it being multiplied by itself? Well, that's the job of this little number, which is called an exponent. So an exponent tells how many times to multiply the base, which is that big 5, by itself. So our number here, 5 cubed, and we'll talk about that in a second, is really 5 times 5 times 5. The 3 says multiply the base number 5 by itself 3 times. So if I multiply, I do 5 times 5, excuse me, is 25 times 5 is 125. Okay? So we've got our base. We have a couple ways to read this. So this is kind of a generic one. So this would be read as... Okay. Oops, sorry.
So I'm going to go to my next screen,
Hello.
But this is still on your first...
Wow, sorry. A little hint that was me talking. We have 5 to the nth power. Let's change the color. So we'd say 5 to the, and then you'd name the number, and you'd usually say a th at it, nth power. Now there are a couple of exceptions to this. The first exception that we just saw was if you have an exponent of 3, then we don't say 5 to the 3rd power. We're going to say 5 to the, or 5 cubed. Because when we multiply something by itself, then we are cubing that number. Okay? And the other exception is if the exponent is a 2. And then we would read that as 5 squared. Okay, so those are the only two major exceptions. Everything else kind of follows the pattern of 5 to the blank nth power, whatever the number is. So let's talk about a word that I did mention, and that was the word factor. So let's make sure we define that. So a factor is a term that is being multiplied by another value. So whenever you're multiplying, the numbers involved in the multiplication are called factors. So I'll give you an example of that. So let's say we have 5 times 3. We would say 5 and 3 are factors. Okay. Now, let's talk about an answer we get if we multiply a number by itself. If we multiply a number by itself, we get something called a perfect square. So that's the product of multiplying a number by itself. So an example would be, if I took 4 and squared it, that would be the same as saying 4 times 4, which gives me 16. 16 is called a perfect square. So the answer of multiplying a number by itself is called a perfect square. And then we also have a perfect cube. And that's the product of multiplying a number by itself and by itself. So an example of that would be 3. No, let's try a different base. Sometimes it gets confusing where they're the same. We'll just stick with 4. 4 cubed would be 4 times 4 times 4, which would be 16 times 4, which would give me 64. So 64 is called a perfect cube. Okay? All right. I'm going to go to my next screen. So let's go ahead and practice how we would use powers and exponents. So one set of directions that you might see would be write each product, or let me try that again. Write each as the product of the same factor. Okay, so this has another name. This is called expanded form. Okay. Then we're going to find the value. Okay, and that's what we call standard form. So typical answer you get when you do multiplication would be called standard form. Okay. All right, so let's see what we got. Let's do 4 cubed. Or 4 to the 4th power, sorry. 4 to the 4th power. So first things first, we're going to write it out in expanded form. So here's the product. 4 times 4 times 4 times 4. And I stop when I have the same number of 4s as the exponent tells me. Okay, so that's expanded form. Okay, so I'm going to write that in parentheses, just an abbreviation. Expanded form. Then I'm going to go ahead, so this would be considered an answer. Then I'm going to find its value. So what I'm going to do is kind of do it in groups. So 4 times 4 is 16. And 4 times 4 is 16. Now off to the side, let's see, we get 36, we get 96, placeholder 6, 1, 6, 5, 2. And we get 256. Okay? And that's the second answer. Pretty straightforward, right? Okay, let's do another one. So, here. All right, sorry. I'll write standard form. Boy, and one thing you're going to find out is we get that standard form means a lot of different things in different situations. All right, for number 2, we're going to take a decimal and we're going to square it. So we're going to start by expanding it. 1.5 times 1.5. Look at all those dots there, huh? So what we're going to do is, remember, when we're multiplying numbers, we're just going to, or decimals, we're going to forget about the decimals, and we're just going to multiply as if there's no decimals there. So we get 25, that gives me 7, placeholder, 5, 1. So we get 225. However, there's 2 digits after the decimal point, so my answer is also going to get 2 digits after the decimal point. So I get 2 and 25 hundredths. Oh,
later.
sorry.
Bye-bye.
It's me again. There we go. All right, let's try another one. Let's try a fraction. Let's take 1/2 and let's cube it. So first things first, we're going to write it as the product or expand it. So it's 1/2 times 1/2 times 1/2, okay, which I'm going to show you over here means the same thing as I'm going to cube the numerator and I'm going to cube the denominator. And then we're going to do math. So if you think about it, it's just going to be 1 times 1 times 1 times 1 in the numerator and 2 times 2 times 2 in the denominator. Now, these numbers are pretty small, so most of us can do this in our head. 1 times 1 is 1 times 1 is 1. 2 times 2 is 4. 4 times 2 is 8. So our 2 answers are the 1/2 times 1/2 times 1/2 and the 1/8. All right, I got another one that's a little bit strange looking. We have 6 squared, and we want to subtract 3 squared from it. Okay, so we're going to have to do this in steps. Step 1, do the exponents. So we're going to kind of expand in our heads and multiply the numbers out. So this is just going to be 6 times 6, which is going to give me 36. And then operation stays the same. And then 3 squared is 3 times 3, which is 9. The second step is going to be do the math. So in this case, it told us to subtract, so off to the side, I'm going to subtract. I have to rename, that's going to give me 27. So my answer is 27. Okay? All right, so we're going to do 2 more, and we're going to go the other direction. So this one says, write each product. So what we wrote up in blue on those top 3, using an exponent. Exponent. All right, so this has a special name, and this guy is called exponential form. So when I write my repeated multiplication problem using an exponent, it's called exponential form. Now this is so easy, it's just It's just so easy. So you might see something that looks like this. Your book still likes to use the X. I tend to use the dot. So what we do is we identify the base. That's the number that you're seeing multiplied repeatedly. Then we count up how many times it shows up. 1, 2, 3 times. That's it. There's your answer. Done. I don't need to figure out the answer. Last one. Let's say we have 1/7 times 1/7 times 1/7 times 1/7 times 1/7. Okay, so let's see, the base, the number that's getting multiplied by itself repeatedly is 1/7, and all I need to do is to count up how many times. 1, 2, 3, 4, 5. And there's your answer. So the only thing that is interesting about this one, if the base is a fraction or factor. Let's try that again, shall I? Fraction or decimal. You must use parentheses, like we did in last chapter with ordered pairs, but for a different reason, to separate it from the exponent. So let me give you a quick example of how this could be a problem. If I didn't use an exponent and I wrote like this, that only looks like I'm raising the 1 to the 5th power, but not doing anything into the denominator. So that's why that's no bueno. All right, there you go, guys. We'll talk about this in class. Bye now.